Hi, I'm here with Rowan from SIMEC Atlantis Energy. Hi there, Rowan. How are you
Hi,
doing?
how are you? I'm good, thanks. How are you?
Yeah, very good, thank you. So we're just going to ask you a little bit about your role
Mm.
and how you got into it. So first of all, can you tell us a little bit about the part of the business where you work?
Okay, cool. So, SIMEC Atlantis Energy are a renewable energy developer. They have three main projects that they work on, or different types of energy. There's the waste to energy business, which is converting an old coal-fired power station into a waste to energy power station down in Cardiff. They have a hydropower operation, so the former Green Highland Renewables hydropower, uh, about 40 different hydropower projects in the north of Scotland and the Highlands. And then there's the tidal power development, which is where I work. And they have two different departments within that. They have the project development department, which takes an area that has high tidal flows and develops the site. And then they have the technology developer that develops the tidal turbines that generate electricity from tidal power. Uh, and I work
Wow,
within the
amazing.
tidal projects department.
Right, okay, so you're in that one.
Yeah.
And what is your role within that? And how long have you been in that role?
So I'm a structural engineer. That's my background. So uh, looking at forces and stresses within materials to make sure they won't break. I've worked in this role for the last 4 years. So yeah, since
Hmm.
2016.
Fab, amazing. And is that when you started with the company?
That's when I started with SIMEC, yeah, SIMEC
Hmm.
Atlantis. Yeah.
Oh, fantastic. So did you do any further study after school, or did you join the company straight from school?
So I graduated from school a long, long time ago now, 16 years ago maybe. So after school, I went on to do my A-levels, um, maths, physics, and chemistry, and then
Mhm.
went on to do a master's in engineering at Edinburgh University.
Right. And was that a few years as well
That
at
was
university?
a 5-year course.
5 years. Oh, fantastic. So I guess what I'd like to know now is what does your current role involve? So tell
Hmm.
us about a typical day in your role.
Yeah, it's a very good question. I guess there's no typical day
Mm,
in this company because it's such a small company, and they're involved in lots of different things. I guess my background as a structural engineer, my typical piece of design work would be looking at a steel structure that's going to be lifted off the back of a vessel and placed on the bottom of the seabed and hopefully stay on the bottom of the seabed for the next 25 years, and support the loads of the turbine to make sure the turbine doesn't get washed away by waves and tide. So that would be
right.
a typical day would be designing a bit of steel to make sure it doesn't break.
Yeah, absolutely. And is that a problem that might exist, that it might get washed away?
Oh, definitely. That's one of the biggest fears, um,
Wow.
because it's a very a high energy site. It's some of the highest tidal flows in the world. So uh, the water moves about as fast as you can jog. So the water moves very, very fast, and it applies a huge force on the steel and on the turbine. And because no one's done this before, no one really knows how big the forces are going to be. So first you have to see how big the load is going to be, and then you have to design the steel to be big enough to take the load. And obviously, there's always a demand and a requirement to make the steel as thin as possible and as cheap as possible. But then you, as an engineer, have got to make sure that what you're designing is going to be big enough not to get washed away.
Hmm. That sounds like there's a lot of things to consider and a lot of different skills needed for this job.
Yeah,
What would you say are the sort of key skills that you need for your current role?
I think, as I said, it's very varied. So
Yeah.
one day I can be offshore, and then when you're there, you need to be able to work well under pressure, because you have very small windows when you can operate and do work. So you need to be cool under pressure. But when you're
Yeah.
back in the office, I think you need quite a good attention to detail. And so my lights have
Mm.
just gone out here.
Oh. Get
No one
us
else
on
is
the
all.
engineering skills there, see if we can fix that problem.
Yeah.
Oh, that's absolutely fine. We can still see you
Okay,
okay.
that's good.
Yeah.
But I think, yeah, so the two key skills would probably be to work well under pressure when you're offshore, and then a real attention to
Mhm.
detail, because everything that you put subsea matters. So you need to worry about the materials, you need to worry about the stresses it's going to be under. You need to make sure you're not blindsided by something that you haven't considered. So you really do need to sit down and think for quite a long time, um, to cover your bases and make sure you're not too stressed out about what you're putting subsea.
Yeah. Oh, fantastic. So what would you say you like most about your current role?
Uh, Probably when I get out of the office and I get to see something I've designed or I've worked on, and you get to see kind of these big 200, 300-ton structures be lifted onto the back of a ship and then lifted subsea. It's a really amazing feeling, to be part of that.
Yeah. Oh, wow. I know. I can't even imagine.
Yeah,
That sounds really amazing. Something that, yeah, I can't even imagine. But it
yeah.
sounds really cool. Um, have you considered continuing studying after you join the company? So, after your master's, is there a
hmm
place you can move on to after that point?
Yeah. So there's the engineering council. So if you're a civil engineer, you can be part of the institution of civil engineers. The same for mechanical, chemical, and electrical engineers. And they ensure that you continue your professional development once you've graduated. And once you graduated, a lot of engineers would move on to become chartered. So after about 3 years a minimum to whenever you like, up to about 10 to 15 years after you graduate, you can become chartered, and that's kind of a stamp to show that you've continued your professional development, and you can you can sign off different calculations at that point.
Oh, right. And so, what does that mean to say that you're chartered?
I mean, you have to go through a process of showing that you've continued your professional development, and
Hmm.
you have to go through an interview and be interviewed by a panel of other engineers. I haven't done it yet, so I don't know
Right.
the full thing. And different engineering councils have different chartership methods. So the Institute of Structural Engineers, they have another exam. It's I think it's a 12-hour long exam that you have to pass. Uh, the Institute of Civil Engineers, you have to write a 10,000 word essay and then go to an interview and pass the interview. So there's lots of different routes to chartership and lots of different things, but part of
Hmm.
it is showing that you're continuing your professional development and staying up to date with the developments in the engineering industry.
Absolutely. And so it sounds like still your communication skills and like writing skills are
hmm
important as well if you're continuing on with interviews
Yeah,
and different exams as well.
yeah,
Yeah.
definitely. I mean, I think your presentation skills as an engineer, you'll always be presenting your ideas, your concepts, your
Mhm.
design solutions to other members of the team, to your manager, to your boss, to lots of different people. And you'll always be writing reports. So it's not just a case of sitting down and doing some calculations and scribbling on the back of a piece of paper and then handing them over and saying it'll be fine. You have to write up your thought process and put it down on.
Yeah.
So there's definitely a lot more to being an engineer than just the mathematical side of things. You do need to be able to convey your concepts and ideas in a semi-legible form that someone else understands.
That's really interesting. I think it's quite good to know as well that there's loads of different sides to it as well.
hmm
It's not just maths, as you say.
Yeah.
There's lots more to it.
hmm
Um, so knowing what you do,
hmm
what advice would you give to students that are still in school?
hmm I mean, I would say so. Maths is definitely the fundamental underpinning of everything that an engineer does. And when I studied maths, I found it quite difficult because it seemed quite abstract. But then once it's applied in the real world, it seemed to make a lot more sense to me. So, when you just sit down and you differentiate something, you kind of wonder what's all this about. But if you have a real world concept of why you're differentiating something, um, it seemed to click for me, and it made a lot more sense. And then when you could apply it with a lot more confidence. So I think it was looking for world reasons for why you would be learning the maths you're looking at. Um, Something else would always be to try and be as broad as possible as well in your understanding. I guess every role that you'll go into will be very, very varied. It'll be quite unlikely that you'll specialize in just one thing. So like I said, I'm a structural engineer, but I'm often managing projects. I'm often talking to electrical engineers about their pieces of design and mechanical engineers about their. So having an understanding of all the different facets of engineering and science is really, really helpful. So try and be as broad as possible. Do specialize in something, but try and have a good understanding and base of all the different areas of science that you're interested in.
Oh, fantastic! Thank you. That was a really good answer and really covered a lot of different bases. So thank you so much.
No problem.
Thank you as well for answering all those questions. That's all we have for you here today. And thanks very much for coming along.
No problem at all. Nice to meet you. Thank you.
Nice to meet you too. All right. So we'll sign off for now. Thank you and goodbye.
Thank you. Bye.
Bye-bye.